Our Earth is being pulled toward a gigantic, mysterious object in space. At this very moment, you are hurtling through the universe at unimaginable speeds. Our entire galaxy is moving towards something gigantic, something invisible, and something that keeps astronomers awake at night. We're going to take a closer look at this, so be sure to stay tuned until the end. Welcome, everyone. As you watch this video, we are moving through space at an incredible speed. And the crazy thing is, you don't feel a thing. Our Milky Way is being pulled by enormous cosmic forces, floating in a giant bubble and part of structures so gigantic that our brains can barely comprehend them. Before we reveal the answer, write your guess in the comments. What is the largest structure in the cosmos? What do you think? But don't worry, we'll clarify that in a moment, of course. And if these fascinating mysteries of the universe excite you as much as they do me, then go ahead and subscribe right now. It costs nothing, you won't miss any more videos, and it really helps me out. If you've already subscribed, giving this video a thumbs up helps a lot. Let's try to hit 5,000 likes. Thank you, everyone. Let's begin our cosmic journey with one of the greatest mysteries in astronomy. Imagine an invisible force pulling not only our galaxy but hundreds of thousands of other galaxies in its direction. For decades, scientists didn't know what was hiding there because it was beyond the so-called zone of avoidance, concealed behind dense clouds of dust and gas. Only modern telescopes revealed the truth. In the 1970s, astronomers made a discovery that initially baffled them. They were studying cosmic background radiation, which is essentially the afterglow of the Big Bang. In doing so, they discovered that our galaxy is not only moving due to the normal expansion of the universe, but is also being pulled by something else, something invisible that is pulling hundreds of thousands of galaxies in its direction with unimaginable force. It's not Kirby, I can spoil that much already. But the speed at which we're moving is really hard to comprehend. About 390 meters per second, which is equivalent to about 1.4 million kilometers per hour. Since you started watching this video, you've already traveled tens of thousands of kilometers through space. For a long time, it was completely unclear what was causing this force. Astronomers gave it a simple but somehow ominous sounding name, the Great Attractor. But what is behind it? A gigantic black hole? An unknown form of matter? Finding the answer was anything but easy. The biggest problem in researching the Great Attractor is its location. It is located precisely in the so-called zone of avoidance. This refers to an area of the sky that is obscured by the disk of our own Milky Way galaxy from our position. Imagine you want to take a photo of a distant mountain, but your own house is standing directly in front of your camera. That's exactly what happened to astronomers. Stars, gas, and dust clouds in our galaxy blocked the direct view of the mysterious object, so we knew we were being pulled by a powerful object, but we couldn't look where the object should have been. Material for a sci-fi horror film, Zone of Avoidance, Part 2 with Tom Cruise. I definitely watched that in the cinema. For decades, researchers could only study the Great Attractor indirectly. Through the movement of galaxies all falling in its direction. It was like trying to understand an invisible magnet by only observing how metal shavings move in its direction. The first estimates of the mass of this cosmic monster were simply unimaginable, about 10 quadrillion solar masses. To put that into perspective, the heaviest known black hole in the universe weighs only 66 billion solar masses. The Great Attractor would therefore have to be 150,000 times more massive than the heaviest known single object in the cosmos. Fortunately, observation methods continued to evolve. With modern radio and infrared telescopes, it was finally possible to see through the dust veils of the Milky Way and see what was really hidden there. And when they looked closely with this modern technology, they finally saw it, the Great Attractor. Instead of a single gigantic object, astronomers found a huge collection of galaxies. The Great Attractor turned out to be not a mysterious single entity, but the gravitational center of a vast cosmic structure called the Laniakea supercluster. Laniakea is Hawaiian and means immeasurable sky. Quite a fitting name for a structure that is 520 million light years across and contains 100,000 galaxies. Our Milky Way is only a tiny component in this cosmic network. We belong to the smaller Virgo supercluster, which in turn is only a branch of Laniakea. The Great Attractor is simply the deepest gravitational well in our cosmic neighborhood, the point toward which all matter in this region of the universe falls. We are a tiny leaf on a larger tree, which in turn is just a small part of a gigantic cosmic jungle. This discovery helped solve one of the greatest mysteries in cosmology. The large-scale structure of the universe. The universe is not chaotic, galaxies are not distributed randomly, instead, they form a gigantic cosmic web of filaments, knots, and huge empty spaces called voids. Here you can see the cosmic web that results from this filament structure. This structure arose from tiny density fluctuations shortly after the Big Bang. Areas with slightly more matter attracted further material through their gravity, while empty regions became increasingly empty. Over billions of years, gravity formed the enormous structures that we observe today. The Great Attractor is basically the largest node in our part of this cosmic web. But will we ever get there? At our current speed, it would theoretically take us about 95 billion years to reach the Great Attractor, but the expansion of the universe throws a spanner in the works. Since the late 1990s, we have known that the expansion of the cosmos is actually accelerating. This is probably due to the mysterious dark energy that makes up about 70% of the universe. This accelerated expansion has a paradoxical consequence. Although we are moving toward the Great Attractor at enormous speed, the space between us and it will grow faster than we can overcome it. Imagine two ants sitting on your stomach, running toward each other, but in the meantime you eat so much pizza that your stomach gets bigger and bigger. At some point the ants will move away from each other even though they are running towards each other. The same thing will happen to us with the Great Attractor. We will never reach it. In fact, this is only the beginning of a cosmic farewell of gigantic proportions. Today, the observable universe spans about 93 billion light years and, according to the latest estimates, contains up to 200 trillion galaxies, but only a tiny fraction of this, about 40 galaxies in our local group, is permanently bound to us by gravity. Everything else will be torn away from us forever in the long run. With every second that we are unable to travel intergalactically, we lose the chance to reach other galaxies at all.
Maybe that's the solution to the Fermi paradox. It simply takes too long to develop the necessary technology, and by the time an intelligent species has it, other galaxies are already out of reach due to cosmic expansion. We're all sitting alone on our cosmic islands, knowing that others must exist, but will never be able to reach each other. A good metaphor for interpersonal relationships now that I think about it. At first that sounds depressing, but I actually find it fascinating. The Great Attractor shows us how dynamic and transient the universe is.
It also reminds us that we are part of gigantic cosmic currents that extend far beyond the solar system. At the same time, research shows how clever humans can be when it comes to overcoming observational obstacles and unraveling the mysteries of the cosmos. Without radio telescopes, infrared observation, and sophisticated motion analysis, we would know practically nothing about Laniakea or the Great Attractor. The fact that we will never reach it makes it a kind of unattainable horizon, a goal we will forever aim for without ever touching it.
Unbelievable, isn't it? But it gets even bigger. Because while we thought Laniakea was already the end of the line, astronomers have now discovered that we might actually be part of something even more immense. The Shapley Concentration, a megastructure that could be up to 10 times larger than anything we knew before. Researchers analyzed over 56,000 galaxies to make this incredible discovery. What does this mean for our understanding of the cosmos? The answer is coming up now.
To understand what the researchers have discovered, we must first look at how astronomers have understood the structure of the universe to date. Imagine the universe as a huge city. Individual galaxies, such as our Milky Way, would then be something like houses. Several galaxies bound together by gravity form galaxy clusters, which are essentially the neighborhoods of our cosmic metropolis. And many such galaxy clusters in turn form superclusters, which can be imagined as entire city districts. As we already know, our supercluster is called Laniakea and spans over 500 million light years, so it would take 500 million years at the speed of light to travel from one end to the other. During this time, the Earth would have changed dramatically, continents would have shifted, new species would have emerged and become extinct again, and you would still be on your way. However, a new study led by Dr. Wallad from the Leibniz Institute for Astrophysics in Potsdam suggests that even Laniakea could be only a small part of an even larger structure. The researchers call this megastructure the Shapley Concentration, named after the astronomer Harlow Shapley, who first observed it in the 1930s without fully understanding what he had seen. How did the scientists come to this conclusion? They studied the movements of no fewer than 56,000 galaxies. To do this, they used data from the Cosmic Flow 4 catalog, which is the most comprehensive collection of galaxy distances and velocities to date. With this data, the researchers were able to reveal something fascinating. They identified so-called gravitational basins in the local universe. These are huge cosmic valleys into which galaxies flow like raindrops. Gravity pulls them toward the lowest point. Dr. Brent Tully from the University of Hawaii, one of the co-authors of the study, explains it this way. Our universe is like a giant web, where more galaxies lie along filaments and gather at nodes where gravitational forces pull them together. Just as water flows within watersheds, galaxies move within cosmic basins of attraction. These lines show the most likely paths along which galaxies move. If you follow these streamlines, you can see how they gather in certain regions, and these are the centers of the basins of attraction. Dr. Wallet and his team have used this method to create a kind of probabilistic map of the local universe. For our Milky Way, it looks like this. With a probability of about 58%, we belong to the Shapley gravitational well. At the same time, we are 40% attracted to Laniakea. Now you may be wondering, what does all this mean? For one thing, it shows us once again how unimaginably large and complex our universe is. We thought we had already found the largest structure in our cosmic neighborhood with Laniakea. On the other hand, this discovery helps us to better understand the movement of galaxies. This is because these gigantic gravitational basins influence how galaxies move through space. Dr. Eskenkorchi, also from the University of Hawaii, explains, this discovery presents us with a challenge. Our cosmic investigations may not yet be large enough to capture the full extent of these immense basins. We are still looking through giant eyes, but even these eyes may not be large enough to capture the complete picture of our universe.
And the Shapley concentration isn't the only massive gravitational attractor that researchers have identified.
And the Shapley concentration is not the only giant gravitational well that researchers have identified. They have also studied one of the largest known structures in the universe to date, the Sloan Great Wall. This gigantic band of galaxies is 1.4 billion light-years long. For comparison, that is about 3 times the diameter of Laniakea. The study shows that the Sloan Great Wall forms the largest gravitational well in the region of the universe studied, with a volume of about 15.5 million cubic megaparsecs. 1 megaparsec is about 3.26 million light-years. Thousands of galaxies like our Milky Way could fit into this volume. Of course, this raises new questions. How did these gigantic structures form? What role does the mysterious dark matter play in this? And are there perhaps even larger structures that we have not yet discovered? The study also provides important clues about the distribution of dark matter in the universe. This invisible form of matter plays a super important role in the formation and development of these cosmic structures. The gravitational basins identified by the researchers are thought to be formed by the gravitational effect of dark matter. Another exciting aspect of the study is the investigation of cosmic flows, that is, large-scale movements of galaxies caused by the gravitational forces of large structures. The researchers were able to show that our local group of galaxies is moving toward the Shapley concentration at a speed of about 630 kilometers per second. Dr. Walled's new study helps us to draw an increasingly accurate cosmic map of our surroundings in the universe, and who knows, maybe we will have to rewrite our cosmic address in the future. Every new discovery like this brings us a little closer to understanding our cosmic home. Now things are about to get truly epic, because if we zoom out even further, the largest structure of all is revealed, the cosmic web. This gigantic network of galaxy filaments stretches across the entire observable universe. And now researchers have made a groundbreaking discovery using radio data. The cosmic web is shaken by powerful shock waves and is magnetic. This discovery completely changes our understanding of how matter is distributed in the universe. Let me show you exactly what's happening there now. The end of the Oort cloud, the gravitational boundary of our solar system, is more than a light-year away from us, and that is just our solar system, our cosmic home. According to recent estimates, the Milky Way, our galaxy, is over 200,000 light-years across, and then, besides the Milky Way, there are up to 1 trillion other galaxies. The universe as a whole is estimated to be 93 billion light-years across. It's all unimaginable, I know, but it gets even more incredible. The structure of the universe as a whole can be represented as the so-called cosmic web. You can see it here. Here we see the matter structures of the cosmos packed together into filaments. These filaments consist of all the cosmic stuff we know, nebulae, galaxies, galaxy clusters. We are currently sitting on one of these filaments in the Milky Way, but the cosmic web doesn't just show filaments, it also contains mysterious voids, gigantic empty areas of the cosmos between the filaments. So we see that matter is not distributed completely evenly throughout the universe. In addition to huge super dense regions of galaxy clusters, there are also large cosmic areas where there is basically nothing. Sure, here and there a galaxy may be floating around in a void, but on the whole it is empty space. So this is the largest scale structure of the cosmos, the cosmic web, consisting of filaments and voids, and as if that weren't bizarre enough, scientists have now succeeded in detecting magnetism in the cosmic web. Dr. Tessa Wernstrom, one of the researchers involved, says magnetic fields permeate the universe, from planets and stars to the largest spaces between galaxies. Many aspects of cosmic magnetism are not yet fully understood, especially at the scales seen in the cosmic web. What exactly did the researchers do? They used all kinds of data and radio maps from sky surveys such as the Global Magnetoionic Medium Survey, which were obtained using radio telescopes such as the Murchison Whitefield Array in Australia. Radio telescopes can be used to map the entire sky in the radio range and see where the highest density of radio emissions is located. The researchers then superimposed this data on the distribution of radio emissions in space onto the simulated structure of the cosmic web, and the end results seem to confirm one of the most exciting cosmic hypotheses. It has long been suspected that when cosmic matter merges into filaments, shock waves of unimaginable magnitude are generated. These shock waves emit radio emissions, which theoretically cause the cosmic web to glow in the radio spectrum, but this could never be clearly proven because these signals are so weak.
Until now. Because that's exactly what researchers have now achieved. They have been able to detect the radio emission of the cosmic web because when they gradually overlaid the radio mapping of the cosmos onto the simulated structure of the cosmic web, it fit perfectly. So basically, it's astronomical detective work. By the way, the amateur astronomers among you know what the technique is called that the researchers used when they overlaid the radio images: stacking.
The researchers have recorded radio emissions emanating from shock waves across the cosmic web, which in turn are created when large structures of matter collide. And this is the first observational evidence ever that accelerated particles in the form of these shock waves are at work in the universe. Or as Dr. Tessa Wernstrom says, in the past, we've only observed these radio shock waves directly during collisions between galaxy clusters. However, we believe that they also exist in cosmic filaments. So the largest structure in the cosmos is being shaken by powerful radio shock waves. So far so good, but some of you are probably already wondering what this radio glow has to do with the magnetism of the cosmic web. A lot. Imagine you are an electron, a negatively charged particle. You're flying relaxed through the cosmic web, thinking about that attractive proton that has been smiling at you for days. Suddenly, you're steered onto a fixed path and become part of a kind of current. What happened? The magnetic field of the cosmic web has captured you.
The radio waves in the cosmic web are mainly generated when charged particles such as electrons are accelerated in magnetic fields. The magnetic fields in the cosmic web thus act as accelerators, guiding the electrons onto spiral paths from which the radio emission is then radiated. This means that by observing the radio waves, astronomers can map the magnetic fields of the cosmic web and measure their strength and orientation. In turn, this helps to better understand the structure of the cosmic web and its interactions with galaxies and galaxy clusters. Okay, I can already hear some of you asking, why is this strange man from the internet telling me all of this? The whole thing isn't as abstract as it sounds and actually has very practical effects, even on us.
The formation of galaxies, their grouping into galaxy clusters, all of this is controlled by shock waves and the magnetic paths of the cosmic web. These completely abstract processes in the largest structure of the universe are ultimately responsible for our Milky Way forming the way it did. Because through some magnetic path in the cosmic web, at some point in the universe, in some filament, exactly the right amount of hydrogen came together to eventually form the billions of stars that make up the Milky Way. It's incredible. I hope you now have an exciting insight into the gigantic structures that shape our cosmos. And we have learned once again that the universe is full of wonders.
Of course, I'll keep you updated on any further discoveries. So if you haven't already, make sure to hit the subscribe button now so we can reach 400,000 on the channel. And now let's leave the cosmic megastructures behind and travel to the edge of our own solar system.
The Voyager probes have discovered something incredible there, a gigantic wall of fire surrounding our solar system. To learn all about this groundbreaking discovery at the edge of what we know, and to see the spectacular data from the Voyager mission, be sure to click on the video in the upper right corner. It's very exciting. As always, you can find another exciting video about science and space in the lower right corner. Otherwise, I'd say see you in the next video. Take care, folks.